In this video, you will learn how to use the switch case statements in Arduino by controlling LEDs using a potentiometer. You can find the code and the circuit diagram for this project linked in the description below. So let's get started. This is what the general structure of a switch statement looks like. You have multiple cases being evaluated against a particular variable. So if the value of this variable matches any case here, the code for that case will be executed. So for example, if you have a value here of 3 and then the variable you are evaluating has a value of 3 as well, it means that the code for this particular case will be executed. But in the case where you have maybe 4 as the variable and then this one being 3 doesn't actually match that variable, it means that this particular case will be skipped. So let's assume that this one has a value of 4. This means that the code is going to skip this particular case since the value here doesn't match the variable being evaluated. After skipping that, you can come over to this one, evaluate the value, and since this one is actually 4, the code for this one is going to be executed. Also note that you can have multiple cases as much as you want. And then in a case where we don't have any case that matches the switch variable here, it's just going to execute the code in a default block. And finally, the break keyword. This just terminates the code after a match has been found. So if we have 4 here, once the code for this particular case has been executed, the break keyword is going to stop the operation. So this stops it from moving on to the next case and then evaluating it. Since we already have a match, the code is going to stop at that point. Next, we'll look at an example. So we'll start by creating variables for the LEDs and the potentiometer. The first one is going to be called green LED. And it's going to have a value of 8. This is because we connected the green LED to pin 8 on the Uno board. We're going to do the same for the yellow and the red. So yellow LED is going to have a value of 9, which denotes pin 9 on the Uno board. And then we'll have the red LED with a value of 10. And then we can create a variable for the potentiometer. I'll call this pot pin. We connected our potentiometer to an analog pin A0. So we assign the value of A0 here, followed by a variable that we're going to use to store the actual value of the potentiometer. We can call this pot value. Now, the potentiometer by default gives you a range of values from 0 to 1023. But for this project, we only need values from 0 to 4. So we are going to have to map through that. And then I'm going to store that in a variable called map pot value. I'm going to show you how to do this later on in the project. So we're going to call it map pot value. Okay, so moving on, we can set up our LEDs as outputs components. So you can say pin mode green LED. I'm going to set this as outputs. You can do the same for 3 pins. So the first thing we'll do here is to get the readings of the potentiometer. I remember that we created a variable here called pot value. So now we're going to make use of it. So we can start by saying pot value is equal to analog read. The analog read function gives us access to reading values from analog pins. I remember that our pot pin has an analog pin or is connected to an analog pin of A0. So now we can reference this pot pin as the pin we want to read using the analog read function. So its parameter is going to be pot pin, which is this pot pin here. So basically what this line of code does is analog read reads the value of pot pin, which is pin A0, and then stores that value in the pot value variable. So you can verify that this configuration works by printing pot value to the serial monitor and checking if the values change as you tune your potentiometer. So I'm going to use the serial.println function. Serial.println and then use pot value as the parameter. You can also add some delay to this. So I'm going to use a delay of 1 second. Then you can go on and upload your code. Now make sure that you've chosen both the port and the board you're uploading to, and then hit the upload button. Once this is done, you can check the serial monitor to see if the values are increasing or decreasing based on where you're tuning the potentiometer. So at this point, mine is working correctly. So now let's move on to the other part of the code. We can get rid of this at the moment since we don't really need that. Our potentiometer is working as expected. By default, the potentiometer gives us a range of values from 0 to 1023. And in this tutorial, we actually need just 4 values, 0 to 4, because our switch statement is going to have 4 cases. So when the value of our potentiometer is 0, we are going to execute code. When it is 1, we're going to do something else. And that happens for each case. So we're going to have case 0, 1, 2, 3, 4. Meaning that we don't actually need all the values coming from the potentiometer. We can map this in a way to just return 4 or 5 of those values. So we can do this using the map function. And remember that we created this variable here to store that. So what I'll do is mapped port value is equal to map. And then we can pass in a parameter of port value. We are using port value here because this is what we are mapping. We're mapping through the values of port value. And then we can specify the values. So we can start with 0, 1023, 0, and 5. So let's explain what this does. Now, the first parameter here is port value, which is the value that you want to map through. And this is the value where we are storing the readings of the potentiometer. Then we have 0 and 1023, which denotes the range of values coming from the potentiometer. So the lowest is 0 and the highest is 1023. The last set of values here, 0 and 5, is basically telling the map function to return 5 values. So the 5 values start from 0. So we are going to have 0, 1, 2, 3, and 4. So in summary, what this does is it takes the values of the potentiometer and then map them into just 5 values here. So we can start writing the code for the switch statement at this point. So we use the switch keyword and then followed by the variable you want to compare your cases to. We're going to use the map port value here. And then we can create our first case. Now, the first case is going to be case 0. At this point, we don't want to turn on any of the LEDs. So for case 0, all the LEDs will be set to low. We can do this using the digital write function. Another thing to note is that you don't start writing your code directly under the case keyword. You have to indent it. So you can use the tab key on your keyboard to do that. So we can use the digital write function. Now I don't want to keep rewriting this, so I'm just going to duplicate it into 3 places. So you can use the Shift, Alt, and down button to do this in your code editor. So for the first one, we're going to set the green LED to low. So this means it's going to be turned off. We can do the same for the 2 other LEDs. So yellow LED is going to be set to low as well. Lastly, the red LED set to low. And then if you want to, you can print the value of the map port value if you want to see this in your serial monitor. But if you don't want to do that, you can just end by using the break keyword. I'm just going to add the serial.println function and then print map port value. Let's print this out here. And then lastly, we'll use the break keyword. Now recall that what the break keyword does is stop this loop once we've met a match. So in the case where map port value has a value of 0, this means that the code will stop after executing these lines of code. So the break keyword is going to stop it. Now this is for the first case. We can go on and create our second case. So for case 1, we want to turn on either of the 3 LEDs. So we are going to go with the first one, which is green LED. So for case 1, we want to turn on just the green LED, not the yellow, not the red, just the green LED. And we can just copy this code here and then modify it. So for case 1, Again, remember your indentation. We want just the green LED to be turned on. So I'm going to change this to high, and every other thing remains the same. So for case 1, green LED is high, meaning it's going to be on. The yellow and the red will be off, and then you can as well print the value of the variable you are comparing. And we can end this off with the break keyword. So after that, we can create another case, which is going to be case 2. Again, we can paste the code that we've already copied. I'm just going to change yellow to high and add the break keyword here as well. Now for case 2, the green and the red LEDs will be turned off and the yellow LED will be high. So as you're tuning your potentiometer and you get to the value of 2, only the yellow LED will be turned on while the rest will be off. This is also the same for case 1 and case 0, where only the ones with the value of high will be turned on and the ones with the value of low will be off. And we can move on to case 3. For case 3, we want the red LED to be on. So I'm going to paste the code again and modify the code for the red LED, and of course add the break keyword. Lastly, we are going to create a case that blinks all the LEDs. So what we want to do for case 4 is to blink all the LEDs as long as the potentiometer has been tuned to the value of 4. So instead of pasting the code again, we can just write this one from the start. Now remember to add your indentation. And what I want to do first is to turn all the LEDs on. So we are going to do digital brights. Again, I'm going to duplicate this. And then we can start with the green LED. Green LED. We are going to set this to high. We're going to do the same for the yellow and the red. Both of them will be set to high. So yellow LED set to high. And lastly, the red LED. So the logic here is that when you tune all the way to the value of 4 for the potentiometer, all the LEDs are going to be high. But the goal here is to blink them. So what we are going to do is to add a delay and then turn them off. Now remember that this is already in a loop function, so the code is going to run repeatedly. So what it's going to do is it's going to turn on the LEDs and then turn them off as long as you remain in the value of 4. So it just keeps blinking on and off, on and off. So I'm going to add a delay of 500 here, which is like half a second. And then let me just copy all of this. We don't need to rewrite this again. I'm going to copy all of this, paste them here, and then change all the high to low. You can also add a delay of 500 here as well. And then followed by the break keyword. So at this point, our code is complete. Now let's run through this again. So for case 0, all the LEDs are going to be low. This means that when the value of the potentiometer is 0, which is what we have here, this maps through 0 to 4. So when the value of the potentiometer is 0, all the LEDs are supposed to be turned off. And when the value of the potentiometer is 1, only the green LED is going to be on because we set it to high here. Now for case 2, only the yellow LED is going to be on. It has a value of high, and the green and the red LEDs have low. And then for case 3, the red LED is going to be on. Lastly, for case 4, it's going to be blinking since we have all the LEDs turned to high, and then after a delay we turn them off. So this is going to run repeatedly for case 4 until we tune the potentiometer or turn off the board. So now we can test this out and see how it works. Thank you for watching. You can find the code and the circuit diagram for this project linked in the description below. And don't forget to share, like, and subscribe. And I'll see you in the next video.